Now here, in this session, we will going to discuss about the relation between shear force and the bending moment diagrams and the intensity of the load. So that is relation between shear force, comma, bending moment and intensity of the load. Intensity of the load, my dear student. It's a very simple, but it is a very, very important at the time of solving the problems. Now it's a very simple. All of you see, my dear students. First of all, so intensity of the load that is represented with W. Shear force is F. Shear force is F or V, whatever it may be. Shear force is F. Bending moment is M. Bending moment is M, my dear students. So coming to here, W. This is a W. What are the units? Newton per meter. What is the shear force units? Force. It is a Newton. Now coming to bending moment. Force into perpendicular distance. Force is Newton. Perpendicular distance is meters. Newton meter. Now here is moment M. Units are Newton meter. Now, all of you see, my dear students, suppose here is a shear force diagram. It is a shear force diagram, my dear students. So on this axis, variable is length. So on this axis, variable is force. I am considering a small length of the beam, that is called as a dx. Now variable is length of the beam. Now I am considering only a small strip, that is a small length of the beam. Now, so df on this force, force is df. On this axis, force is df. This is in this small length, shear force is df. Now df divided by dx. Here is force, this is distance. What are the units for the force? Newton. What are the units for the distance? Meters. Okay. What are the Newton per meter? What are the unit Newton per meter? Newton per meter is nothing but W. So that df by dx is equals to W. df by dx is equals to W. Now, we are drawing the shear force diagram, my dear students. This is the length of the beam. This is the shear force. Now, it is a graph like this. So it is in a form of df is equals to dx into W. Y is equal to mx. That is a linear curve. Y is equal to mx plus c. That is, when the curve not passing through the origin, it passing some distance away from the origin. See here. Now this is y is equal to mx plus c curve. So the curve passing some distance from the origin. That is y is equal to mx plus c. But here it is passing through the origin. It is in a form of y is equal to mx. This is m. This is x. Now for this is a slope. This is df. This is dx. Okay. This is a shear force diagram. It is a slope. What is a slope? Here is W is equals to df by dx. That is m is equals to dy by dx. Okay, it is in this form. It is in this form. So that the slope of the shear force diagram, it is a shear force diagram. It is a shear force diagram. The slope of the shear force diagram is called intensity of the load. That is the first point. So what is the slope? So y is equal to dy by dx. So it can also written in this form. That is W is equal to df by dx. The slope of the shear force diagram. Force is here, length is here. The slope of the shear force diagram is called intensity of the load. That is a first point, my dear student. The slope of the shear force diagram, the slope of the shear force diagram is called intensity of the load. Intensity of the load. Intensity of the load. That is the first point, my dear students. You remember this one. How to clear about next one? Here, this is about the shear force diagram. Now coming to bending moment. Now, here is a bending moment diagram, my dear students. See, this is the length of the beam L. This is on this axis, bending moment is W. Now, there is a graph like this. Okay? So, for this slope, we know that y is m is equal to dy by dx. Okay? Now, I am drawing a slope like this. Similar fashion. Now, in previous case, that is a shear force diagram. Now, in this case, it is a bending moment diagram. For that bending moment diagram, so this is dm, this is dx. Okay, so similar fashion. This is a bending moment diagram. On this length, on this axis length, on this axis moment. So for a small length dx, bending moment is dm. For a small length dx, bending moment is dm, like this. Now it is like this. Now what is the slope here? So dm by dx. So what are the units of moment? Newton meter. Moment units are Newton meter. Now the distance, this is the length of the beam, that is meters. Meter cancel. We are getting Newton. What is the unit for Newton? Newton is a unit of shear force. So okay, now dm by dx is equals to F. So this is called shear force. So the slope of the, now here is m, this is equals to dy by dx. It is in a form. So that the slope of the bending moment diagram, this is a bending moment diagram, my dear student. The slope of the bending moment diagram is called shear force. This is a second point, my dear student. The slope of the bending moment diagram. Bending moment diagram slope is equals to shear force. What is the second point? The slope of the bending moment diagram is called shear force. Is called shear force. This is a second point, my dear students. Now coming to, you remember these 2 points. You must remember these 2 points. Now I am entering to the next point. It's a very important. There are 4 points here. So you must remember all these 4 points. So what is the first one, my dear students? What is the first one? What is the first equation? df by dx is equals to w. Now dm by dx is equals to f. Very good. Now coming to this equation, what is the df? df is equals to w into dx. w into dx. Now, so see my dear students, it is a load diagram. It is a load diagram. On this axis length of the beam, on this axis intensity of the load. On this axis intensity of the load. Now this is a bending moment diagram. Sorry, intensity of the load diagram. This is a load diagram, my dear students. So, for this a small strip, I am consider for a small length of the beam, for a small length dx. For a small length dx, force, what is force? Force is, what is this? So, here is W, load is W. Load is W. So, here is, I want to find out the shear force between the 2 points. Here is a 1 point, here is another point, here is another point. The shear force between the 2 points. For this small distance, in this, shear force is equal to area of this diagram. What is area? Here it is in a form of a rectangle. It is in a form of rectangle. This is length, height is equals to W. So that for df is equals to area of this, area of the load diagram. Area of the load diagram. Area of the load diagram. Okay, now df is equals to W into dx. I want to find out the shear force between the 2 points. I am integrating this between the limits 1 to 2. Here is 1 to 2. So df, integral of df is nothing but f. So f2 minus f1 is equals to integral of W into x. Okay. So what is this meaning? The shear force between the 2 points. So W into x is nothing but area of the load diagram. So that the shear force between the 2 points is equals to area of the load diagram between the same points. So the shear force between points 1 and 2 is equals to area of the load diagram between the same points. Okay, so here is third point, my dear student, C point. The shear force between 2 points, shear force between 2 points is equals to area of the load diagram between the same points, my dear students. It is a third point. All of you clear, my dear students? It is about the third point. The shear force between the 2 points is equals to area of the load diagram between the same points. Whatever the area between the 2 points, for that area of the load diagram is equal to shear force between these 2 points. Now, coming to another equation, my dear student. What is the next equation? dm by dx is equals to f. dm by df is equals to x, my dear students. So, now coming to dm by dx is equals to f. So, from this, dm is equals to f into dx. F into dx. Now, coming to shear force diagram. On this axis, length of the beam. On this axis, shear force F. Shear force F. Now, this is a shear force diagram, my dear students. Now, I am considering a small strip. For this strip, length is equals to dx. Height is equals to F. What is the area of the strip? Area is equals to rectangle. Area of the rectangle. Height of the rectangle is F. Length of the rectangle is dx. F into dx. Okay. So the total. Suppose we want to find out area between. Suppose we want to find out the. Here is 1 point. Here is another point. Between these two points, how to find out? So we know this small area. We want to get this area. We're integrating this one. Total area between 1 and 2 points. 1 and 2 points is equals to integral f into dx 1 to 2. So this is equals to dm. Now here also we are integrating that one. Integral dm 1 to 2. Okay, total. This is after integrating this one. What we will get? M2 minus m1 is equals to integral 1 to 2 f into dx. So bending moment between these 2 points. Bending moment between the 2 points is equals to area of the shear force diagram between these same points. So bending moment between these 2 points is equals to whatever the area between the 2 points in shear force diagram. For that, this is equal. So what is the bending moment between these 2 points is equals to area of the shear force diagram between these 2 points only. That is the fourth point. Bending moment between 2 points is equals to bending moment between the 2 points is equals to area of the shear force diagram. What is area? This is area of the shear force diagram. That is equals to area of the shear force diagram between the same points. Between the same points. This is another one. This is fourth result. So next, how to clear about this? The bending moment between these 2 points is equals to area of the shear force diagram between these 2 points. That is a fourth result. So now coming to last one. So see my dear students, here we are assuming that there is a one m and m is a equation. There is a m is there, that is one equation. So for this equation, how to find out maximum value? So differentiate this equation with respect to variable and equating to 0. We will get maximum, condition for maximum. Okay? Now it is a one equation here. This is one equation. For this equation, how to find out maximum value? Differentiate this equation with respect to variable and equating to 0. We will get condition for maximum. Now what is variable here? Variable is x, that is length of the beam. So that dm by dx, differentiate with respect to x and equating to 0, we will get condition for maximum value. This is equation number 1. Now we know that dm by dx is equals to f. Already fourth results, already second one. Second result, dm by dx is equals to f. So now left hand side terms are equal, automatically right hand side terms are also equal. That is f is equals to 0. F is equals to 0. So what is the meaning? When shear force is 0, at that point bending moment is maximum. Yes or no? So when the shear force is 0, the point at which shear force is 0, at that point bending moment is maximum. M is maximum. Okay. So all of you clear, my dear students? So when the shear force is maximum, so this is fifth one. So when shear force is maximum, when shear force is zero, at that point, bending moment is maximum in bending moment diagram. When shear force is zero, at that point bending moment is maximum in bending moment diagram. Okay, all of you clear?